Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 8.2 using scientific notation. A little review. There are two requirements for scientific notation. The first is it must be a number between 1 and 10. So it can be 1.0 all the way up to 9.999999999. You can only have one digit to the left of the decimal. The second requirement is it must be your number and then times 10 raised to some exponent. And n, if n is greater than 0, it makes a larger number. If n is less than 0, it makes a smaller number. Okay? So what we want to do is we want to rewrite each expression in scientific notation. The first thing I want to do is I want to find my decimal place. So for the first problem, it's to the right of 55. For the fourth problem, it's to the right of 2,727. The other problems already have the decimals in place. So what I'm going to do is I'm going to move my decimal so that I have a single digit to the left of the decimal. So for each one of these problems, I want to move my decimal. So for the first problem, I end up with 5.5. The second problem, I end up with 6.0. Third problem, 1.0. Fourth problem would be 2.727. Okay? Now, what we have to figure out is by moving that decimal, what does it do to the exponent from the base 10? So this 4 here. Did I increase my exponent or did I decrease my exponent? So if we look up at the second requirement, if n is greater than 0, meaning that it's positive, it makes a larger number. If I were to actually take my number times 10 to that exponent. So when I move my decimal to the left, like I did in problem 1, I'm actually going to add however many places I moved it. In this case, I moved it one place, so my exponent is going to increase to 5. So if I move to the left, I increase my exponent. In problem 2, I'm moving to the right 1, 2, 3 places. So that's actually going to decrease my exponent by 3. So I end up with 6.0 times 10 to the 9th power. On problem 3, I'm moving to the right, so I would decrease by 1, 2, 3, 4 places. So this would be 1.0 times 10 to the, what's negative 9 minus 4? It's negative 13. On my fourth problem, I move to the left, so I'm going to increase by 1, 2, 3 places. So negative 3 plus 3 would actually be times 10 to the 0 power. That's how we would write that in scientific notation. We know that anything raised to the 0 power is actually 1, so this number really would be 2.272. Okay? Moving on. Multiplying. So what do I do if I have two scientific notation numbers that I need to multiply together? The first thing I'm going to do is just multiply my numbers. So 7 times 4 would be 28. And then I have my base 10. If you remember from our last section, we talked about exponents and like bases. So I'm multiplying two like bases. The base is 10. So what do I need to do is add my exponents. So this ends up being 28 times 10 to the 5th power. Now, I have to check and see if I have it in scientific notation. Well, right now, I have two numbers to the left of my decimal, which means I have to move my decimal one place to the left, which means I'll add to my exponent, giving me 2.8 times 10 to the 6th power. The next problem, I'm going to go ahead and again multiply 1.5 times 3. When I multiply 1.5 times 3, I end up with 4.5. Same thing with our base 10. So I have base 10, base 10. So times 10. I'm going to add my exponents because I'm multiplying like bases. So negative 2 plus 4 gets me 4.5 times 10 to the second. Because I only have one number to the left of the decimal, that is the correct answer in scientific notation. My number is between 1 and 10, and I have times 10 to an exponent. Okay? On to 3. 9 times 7 is 63. I keep my times 10. I need to add negative 6 and negative 9. So negative 6 plus negative 9 would be negative 15. At this point, I have two numbers to the left of my decimal, so I need to move it to the left. Anytime I move it to the left, I increase my exponent. So I have 6.3 times 10. Negative 15 plus 1 would be negative 14. On to problem 4. I'm going to go ahead and multiply 5.5 times 4. 5.5 times 4 is 22. Then I have my times 10. Again, because they are like bases, 10 and 10, I'm going to go ahead and add my exponents. So that gets me 22 times 10 to the 21st. Again, my decimal is, or I have two numbers to the left of my decimal, so I need to move my decimal to the left. When I move it to the left, I'll add 1 to my exponent. So 2.2 times 10 to the 22nd would be my answer. So when you're multiplying two scientific notation numbers, you're just actually going to multiply the number that's in front, and then you're going to add the exponents together. At that point, you need to double check if your answer is in scientific notation or not using what we did just above. Okay? On to dividing scientific notation. Because scientific notation always uses decimals, what we can do is actually just divide 2 divided by 8. Just take your calculator, 2 divided by 8. You'll end up with 0.25. That will be times 10. Now, if you remember from our last unit, what we did is we subtracted our exponents when we had a fraction. So I need to subtract 3 minus 8. We are not going to keep this as a fraction, so we don't worry about negative exponents. It is okay to have negative exponents in scientific notation. So when I take 3 minus 8, I end up with 0.25 times 10 to the negative 5th. I need to move my decimal one place to the right, which is actually decreasing my exponent. So I end up with 2.5 times 10 to the negative 6th. Okay? On to the next example. Take 7.5 divided by 2.5. When I take 7.5 divided by 2.5, I end up with 3. Then I have my times 10. I need to take 12 minus negative 4. Write it out exactly the way it looks for yourself, because all of you, when I ask you about subtracting a negative, tell me that when I subtract a negative, it means the same thing as adding. So I'm going to subtract the negative, which is really 3 times 10. I'm going to add 12 and 4, which gets me 3 times 10 to the 16th power. On to the final example, 3.5 divided by 5. Well, 3.5 divided by 5 would be 0.7. I keep my times 10. I'm going to subtract 6 minus 8. So it's 0.7 times 10 to the negative 2nd. At this point, I need to move one place to the right. When I move one place to the right, I'll subtract 1. So I end up with 7 times 10 to the negative 3rd. So all in all, what you're going to do when you have a division problem with scientific notation is you're going to divide the number that's in front of your times 10. Always take the number in the numerator and divide it by the number in the denominator. And then you're going to subtract your exponents. Always subtract the exponent in the numerator minus the exponent in the denominator. It is okay if we have negative exponents. All right, well, that is our lesson for today. Make sure if you have any questions, you either email me or ask me next time you see me. Otherwise, thank you very much for watching the video and have a great day.